let us take another example like 100% para product formation. We know a standard equation that aniline, for example, that is aminobenzene, is called commonly aniline. This aniline, when it is brominated, amino group is a very strong activating, therefore, you does not require a catalyst like ferric bromide. Just a solvent like acetic acid is enough to promote the reaction, and that too the brominations takes place at ortho as well as para and again ortho. So, you will get a tribromoaniline, and that too it will become a light yellow color precipitate also will be formed. And to see the reaction, it is very really fantastic reaction. Aniline is a light yellow or almost colorless compound. When you add this dark brown liquid till you get light yellow and then add enough water and shake it, you will get a almost white color precipitate of tribromoaniline is taking place. The phenomenon is having the two backgrounds. One is amino is a strong activating, therefore, the reaction takes place spontaneously without much catalyst heating or something, just mix well and then add water, that is enough in fact. Second one, going to only ortho para, because amino is a plus M group, makes the ortho minus para minus ortho minus, not the meta. So, it is ortho para directing, okay, right. Now, under these conditions, what we are observing is specific observation. Let us treat this acetic anhydride. Acetic anhydride means acetic acid taken twice both the sides, and it is eliminated a water molecule in the form of anhydride. You add this acetic anhydride, aniline becomes into acetylated aniline, acetyl, N-acetyl, that is COCH3 introduced into NH. This is called N-acetylated aniline, or has a common name once again called acetanilide. Is a common name for this acetylated aniline. Now, this compound also do the same reaction. Reaction takes place, no doubt, because there is a lone pair is there. The lone pair shows activation on the benzene ring, and it is in a ortho para directing, therefore, the reaction also takes place ortho para only. But because of this group, we have some said specific observation. Now, one is it is also taking electron pair may be withdrawn this side because C double bond O with it. Therefore, activation property is slightly decreased. So, therefore, instead of tribromo, only single bromine is coming. And where that comes means because the group is so big, it is amino is considerably small one when compared with this one. Size of this acid, that too single bond, it rotates. So, the big group is rotating on the benzene. So, this bromine is also not a small one, it is an electrophile bromonium ion, atomic weight 80. So, it is considerably bigger atom, and it is attacking not from the ortho, because there is a lot of space problem is going to come. That is why it prefers only from the para. So, almost 100% para bromo acetylated anilines form. Only para, that is almost roughly nearly 100% para bromo acetanilide only product will come. Para bromo acetanilide comes. Now, afterwards you can do one small extension, do some hydrolysis reaction H3O plus, that is water and some acid, boil for some time. The acid group can be detached because this is a amide group undergoes hydrolysis, that side acetic acid is detached, this side aniline is produced. So, finally, what I prepared is I prepared a amino group containing benzene with a bromine only at para. If the question is asked like this, for example, how do you prepare this para bromo aniline? When you add bromine, you will get tribromo. How to avoid the bromination at ortho? It is slightly difficult to understand, but there is a simple technology. So, we are introducing a acid group which has two factors. One is it is deactivating the ring, because through the minus M effect on the amino. Amino is plus M, but the COCH3 is minus M group. So, therefore, activation of amino decreases. Therefore, the tribromination has come to monobromination, and the group size is increased by virtue of the space occupation will be more. Therefore, lot of steric hindrance produces. Therefore, the bromination is only directed to the para only. So, you will get almost a pure form of that para-bromoacetanilide. Afterward, the acid group I do not want, is not it? So, therefore, remove this acid group by way of hydrolysis. In this hydrolysis, bromine is not hydrolyzed, only the bromine in basic medium, strong basic medium only will nucleophile substitute, not with the water at all. So, therefore, the bromine is safe and the acid group is detached and you will get para-bromoacetanilide. So, what is the procedure means? Acetylation, bromination, deacetylation will give this desired para-bromoaniline. So, here we are using that steric hindrance as one of the that is a useful technology. Here we are creating a steric hindrance and adding the bromine so that it goes to the para only, and then removing that steric hindrance, again you will get back the para-bromoaniline. Good procedure it is, but here we have to emphasize that particular how this acid group is making to get a para-bromo alone. This is due to the mainly the steric hindrance is the one of the application.